Let's have a quick, fast video on cracking. This is the, I guess, FDOT's version. Their engineer did this statement here. Cracking will occur here, exclamation point. Cracking will occur here. So does that mean it will fail, that the structure will fail because you said cracking is going to occur here? No, cracking is the failure of the concrete under tension, is what we're referencing. But it's not failure of the steel. It's not failure of the steel, nor is it failure of the post-tensioning. He's not clarifying how he determines cracking will occur, but it appears he means tensioning. So cracking will occur here during phase 1. He believes that the cracking will occur here, he believes. And I'm going to get to you guys about anti-burst with post-tensioning, anti-bursting. I'm doing some research on it now to give you a nice little video on it. But it's C1. This is the back span, not the main span. And he's showing that because I believe he's stating it because these tubes are hollow, no grout in them, and this makes sense to me. This is my extrapolation on this, because I would think the same. As I talked to you guys before about the tubes are hollow, cracking would be, a lot more easily done, because of it's a little bit of distance here before you get a break in the concrete. So this would only be maybe 6 inches or less. He has it appear the force is coming out of here in a 45 off of this, like the plate coming off of here. I think I did one for you guys like a cone also, where I show it like a cone shape. If you treat it like a cone, that's what the post-tensioning bar, not this plate system. So here's the 45, and this is where I believe that these lines extrapolate to meaning as to where the cracking zone would be. I don't know. He's gone pretty far down here. He's got it crossing over the voided area, and then picking up again in the same path. That might be an interesting thought. If anything, he should also probably add spalling would take place here. This piece would come across and possibly spall off this triangle there. Let me see if I can zoom in. This is a ductwork, that area there. But he's not addressing the confinement that they have in here also, the anti-burst, transferring the loads further down. So possibly acting like a truss plate, if you will, the entire area. So possibly cracking down here, in fact. And not in fact, but, in theory. Again, he's gone down this path here. Web diagonal, ditch. I just want to talk about cracking on this one. Cracks will occur here again, and it appears he's doing the 45 rule again, coming off of here, not off of the back of the spiral anti-burst. The spiral anti-burst. See, I'm going to do a video on that. It's a lot of forces here on that plate, and so to help it not burst this area out, cause it to failure, they use spiral, etc. It's a nice document I found for you guys on that. Doing some research on you guys. Cracking will occur here again. So again, cracking doesn't mean failure though. Cracking just means the concrete failed in tension, say the backside of there, and the rebar would take over at that point, or the post-tensioning would make it clamp it back together. But this is the deck. Oh, this canopy appears to be the canopy. This appears to be the canopy. So there's no transverse cables here, so steel would have to take over down here to keep this together still. Steel will take over the loads. And this is the canopy still, and same deal. Except for there, we're at the... Nope, still canopy. ditto, meaning same thing. Isolation pylon during span fabrication at Staywood, right? So again, he has it breaking down. I think that's because of the hollow ductwork. We did not see that though. We did not see it on the bridge structure under, because a couple of ducts were not, and the canopy were not grouted, nor did they have post-tensioning in them yet. It was the outside deals, I think it was, whatever they were next to post-tensioning. Oh, okay. Bear with me. I'll grab it. So through extrapolation, using the drawings now, it appears that FDOT is claiming that because those ducts are hollow at that point, they will get cracking across it. Well, through extrapolation, that means when you do D1, since you didn't do D2 yet, then D2 is not grouted, so D2 should also have a crack in it. And then when you post-tension this, you should be dealing with a crack. And then as you post-tension D2, then that means D3 now all of a sudden gets a crack in it across the diaphragm, meaning here. So as you're doing D1, the crack would then come across here and crack this guy, right? And then you do this one, then it would crack this one, and then this one. It would go down the line per the extrapolation of FDOT's engineers' thinking. There's none over here at all besides the spiral or U-shaped reinforcement, the anti-burst, and that would go over there. But these had anti-burst on them, and we did not see any cracks in the presented like that in the bridge on either end when we looked through the photographs. So I don't see where these cracks would, I don't see them being correct. If we go to the canopy, we know the canopy is lacking some post-tensioning because it's not going to be done until the tying the two structures in. So through extrapolation, since C1 and C2 were done, C3 and C4 were not done. So C3 should have that same cracking that he mentions coming across here, since it's just ductwork. But they're leaving out, for clarity, they're leaving out the anti-bursting material inside here for clarity in the video. And I think it's written over here somewhere that that for clarity, they do that a few times in this drawing. So I'm thinking here also. I'm extrapolating it's here also, that they don't want to put confuse us with the reinforcement. So, what do you guys think of that? So, again, this video is about cracking, though. Cracks don't mean failure. They mean failure in the concrete, the tension. But the rebar then will be bonded to the concrete. And you can't make that structure still deflect and fail until you make the rebar fail. And the rebar won't fail until it fails. And you can make the rebar fail if you would lose your grip force, if you will, your grip inside the concrete. Your grip inside the concrete. I didn't say friction. Your grip inside the concrete. That's why rebar is shaped the way it is. So now, I've got the rebar page, something for you here. See the ribs in the rebar? Well, that's for adding this coupling, but this is your grip. This is how your grip is created, and that's your coupling, clamping it on. But this grip is how it's created in the concrete around it. So you're not going to get failure until you evaluate. You could take apart the underside of a crack, for example, and look at that rebar. Besides looking for simple deflection, but you could look at that rebar and see that this part of the rebar would be in compression, the top part, the loaded part, and on the outside part would be on the tension. That would create a different span between these guys. So if you could measure between these guys, you can tell whether your rebar is being elongated. You can simply look at the concrete and see the crack, how wide it is in the underside, and you know your rebar is going with it, or you'll know that your concrete is slipping around it, in which case that's pretty critical. You'd rather have the rebar failing. That way you still have grip, and you know that you still get a little more time to figure out this issue on how to remedy it. All right, I'm going to get into carbon fiber. I have some carbon fiber I bought, so you guys will understand how carbon fiber is awesome, how it can be used for a lot of repairs and structural reinforcement. It's some great stuff. That's just epoxy coated. Still has the same rib profile, but now you have the epoxy that is working off of gripping around there and up and down the valley, protecting from corrosion, salts, etc. Okay, so when you start getting that rusty rebar expanding, then now you're breaking your grip. You're losing your grip, and you're losing your ability for your structure to stay where it is. How's that? That's another coupler. All right, so you don't want that rebar rusting. You don't want to put rusty rebar into a structure either. Take care, guys. Just wanted to load you up something about cracks, rebar, just cracks in general. Take care.